Hello everybody. So in this video I'll try to discuss some problem where we have to find out the asymptotes and some other properties from our functions. Like, look at this. So this kind of math we will do. So there are a couple of things that we have to do here. So it says in the following problems, find the domain and range of the function, then intercepts, then horizontal asymptote, vertical asymptote, oblique asymptote, if any. So all these things we have to find out from this. These are the maths that I am reading now. This is exercise number 4.2, polynomial and rational functions, page number 197, Michael Sullivan book, 9th edition. So let's try to do first one, 25 number first. Then we will do some maths from this side also. We'll try to do. So let's try it. So first of all, this 25 number. 25 number, I hope you have the worksheet with you. Like, this is the 25 number, this one is the 25 number. So we'll try to solve this one, and let me show you this. I think I can show you from some other sources so that you see the picture nicely. I hope you see it. This is 25 number. So you see, I think you can see there is two red line. One is horizontal red line, another one is vertical red line. Can you see this horizontal one? See, this is a horizontal red line, this one, and there is a vertical red line, this one, this one. So we have two red lines. These red lines is actually the asymptote of this function. So you see this horizontal red line. This horizontal red line is at y equals to 1. That means horizontal asymptote will be at y equals to 1. See the y line, this is y line and this is x line, and the vertical line is at x equals to 2, x equals to plus 2, so the vertical asymptote will be there. So this is how we actually understand from the figure. This is how we actually understand the vertical. You see this is the horizontal asymptote, this is horizontal asymptote, and this is vertical asymptote. That red line dot, they have given this. You can say, sir, how do we know, like, this is the horizontal, this is the vertical? This is given here. We do not have the function, but actual function here is not written here. Although we know which function is this is basically 1 by x function, and it is transformed. So we actually know which function is this, but they haven't given this. Suppose the picture is given. Now how can we find out? That's the point. So if the picture is given, then the vertical and horizontal asymptote will be shown. If it is not vertical and horizontal, if it is oblique asymptote is given in this math, like in the last maths. This is some inclined line. This line, see this dot, this line. This can you see this inclined line is the oblique asymptote. So the symbol will be given. So if you have this worksheet, then you can just have a look, and I'll try to solve it. First of all, let's try to find out now let's solve it step by step. First, a number. This is 25 number, I suppose. This is 25 number. Yeah, let's solve 25 number. Or I can try solving some other maths. 25 number is kind of easy. Let me show you the solution. I will not do 25 number. I have this written here. If you look, this is the solution. 25 number. I think I can. What can I do? Yeah, I think now it is visible. I just have written it here. The domain is like all the value, not the x equals to 2, because at x equals to there is asymptote. That's why asymptote value we have to exclude. Then range value is all the real number except y cannot be equals to 1, because see, at y equals to 1 there is the dot line. That means that is the asymptote here. Then there is one intercept. Intercept is at 0 0 0 0 is the intercept. 0 0 intercept. Do I have a pen? Let me show you by pen. So I have a pen here also. Sorry. Okay. So this is the intercept. Okay, so this is the intercept. Intercept is at 0 0. That's why we said 0 0 is the intercept. Y equals to 1 is the horizontal asymptote. This line is the horizontal asymptote, and this line is x equals to 2 is the vertical asymptote. And for this question there is no oblique asymptote, because oblique asymptote will be like this, some inclined line from any direction. Inclined. It cannot be horizontal or it cannot be vertical. Then that will be some oblique asymptote. We'll try to do this maths. This maths is a little bit one step forward kind of maths. We'll try to solve this maths now. 28 number maths. Let me show you in the mobile also, so that you see the colored version from this. So you see the colored version of this. So I want to show you this maths. So this one. This is the 28 number maths. You see the picture. So we'll try to solve this math. So 25 number, I hope you know now what is the answer of 25. That's the 28 number now. 28 number. So first question is domain and range of this function. A number is domain and range of this function. Now you see if you look at the picture, there is a dot line at the y value, like vertical dot line is c at just at y equals to just at 0 line, x equals to 0. That means all the real number except x equals to 0 will be the domain. All the real number except x is equal to 0 is the domain. Why? If you want, because you see the graph actually stretches. Graph actually goes all the directions. See this graph, the line will go this direction and the line will go this direction. This thing will go this direction and it will continue forever, and our graph will also continue forever. And this direction also we have some graphs. So basically in the x line we have in the all direction we have the graph, except we do not have any graph at 0 line. So we do not have any graph at that 0 line. So that's the point. This is why the domain is that. So this is why the domain is that. Okay. So this is why the domain is that, I can see. And for the range, now we'll discuss the range. And for the range, you will see there is no graph in between this. See, from this to this, there is no graph. Graph start here and down open, start here and up open. So there is no graph here. So we have to exclude this space. We will say this value to that up and this value to down. That is the range. See, we will say from this value to upside and this value to downside. That is the range. We have to exclude this space. How to write it? Let me show you that. So the range will be y, all the real number, and the condition is what type of real number? Condition is y has to be greater than 2. Y has to be greater than 2 and 2 or equals to 0, because it is included, that's why. Then y has to be, then another thing is y has to be less or equals to minus 2, less or equals to minus 2. That's the condition that we have here. So that is the domain and range of this function. Minus 2, why we said minus 2? See this minus 2 value, from this minus 2 value, this downside we have to count. So all the value below down minus 2 is less than minus 2. That's why we said less. So y has to be equal to or less than minus 2. Now B number question is what? Intercept, if any. So in this question there is no intercept. See, in this question there is no intercept, no x-intercept, no y intercept. I mean, you see on the x line or y line there is no intersection of the graph. Graph is going or not touching x line or y line. That's why we are saying there is no intercept here. So we will say none here. Now C number question is what? C number question is horizontal asymptote. So is there any horizontal asymptote? See, there is no horizontal dot line. There is no horizontal red line. So that means this is also none. Then D number, vertical asymptote. You see there is a vertical asymptote at, see, there is a dot line, vertical dot line. There is a vertical dot line here. See this vertical red line. You can see now red line, but in the worksheet maybe you will see it in black, but yeah, in the original book it is red color. So there is a vertical asymptote at x equals to 0. At x equals to 0. That is the vertical asymptote. And now oblique asymptote. In this case, you see there is oblique asymptote here. This red line. See this red inclined line. Inclined line is the red oblique asymptote. Now we have to find out the equation of this line. And interestingly, this equation is nothing but just x equals to minus 1. just x equals to -1 is the equation of this line. How to find out? Let me show you that. How to find out. So our line is kind of this. Okay, I can use actually. Okay, our line is kind of this. So this is that line, and one point is given. This point is called 1 1 -1 1 -1 1. I'm not sure if you can read it. -1 1. I have some other colors also, let me use it. So -1 1. So then we can draw a line like this. To find out the slope. And there is another point here which is 0 0. Always this is our x line if you are interested. This is our y line. So this is our graph, same graph. I'm just showing the line part. Then we can there is two methods now to find out the equation of this line. One is use the both point and then do the calculation to find out. So one point, let's do it that way. One point is this point is 0 0. So this point is 0 0. So our formula here to find out the equation of line is y minus y1 divided by x minus x1, or we can write it like this: y2 minus y1 divided by x2 minus x1, y2 minus y1 divided by x2 minus x1, then x minus x1. Where I can write it here, or I can write it there also. Both sides is fine. Then we can write x minus x1. So that is the formula for finding the equation of the straight line. So we will suppose x1 on y1 is 0 0. So we'll write y minus 0 x minus 0 then equals to y2. So y2 is the second value, that is 1 plus 1 here. y1 is 0. Then we'll write x2 is minus 1, x2 is minus 1, this is the x2. Then x1 is 0, so 0. So basically what we have here after the, you see this all are 0 basically here. So this is y, this is actually y by x equals to 1 divided by minus 1. So in fact if you do the calculation, this is y equals to minus x or x equals to minus 1, whatever you say. So this is x equals to y minus y or y equals to minus x. Okay, you are y equals to minus x. So this is what you can say. I mean, it looks like minus y equals to plus x, but then if we multiply it, then it comes this. So this is the oblique asymptote for this question. So the final answer is y equal to minus x, y equals to minus x, or x equals to minus y, x equals to minus y. Both is correct. Both is actually same thing. Both is actually same thing if you are wondering like what's going on. Both is actually same thing. And for 29 number, if you look at the solution, actually I have written it here some time ago. So this is our 29 number. See the solution. So oh my god, why I have written, so fx equals to x square minus x square divided by x square minus 4. This is actually the original function, although in nowhere in this questions this function is written. I just have written it because it looks like this is the actual equation for this function is this one, but this is not at all needed for this question. So we have to find out the domain, we have to find out the range, we have to find out the intercept, then horizontal and then vertical asymptote, then oblique asymptote. You see there is two vertical asymptote here, one horizontal asymptote here. So basically all of these things is this. Okay, let me tell you the answer of 30 number also. So answer of 30 number will be, the domain will be all real number except x equals to minus 1 and x equals to plus 1. The range will be all real number x except y equals to 0. See that dot line is given here, dot line is given here. Okay, let me show you from the mobile. No, okay, let me finish it from this. So that's it, because I want to make the video below 15 minutes. So all right, then we have this domain and range. Then there is a horizontal asymptote, which is this, which is y equals to 0, vertical asymptote y x equals to minus 1 and x equals to plus 1. That's the asymptote, and there is intercept 0 0, and there is no oblique asymptote. Thank you all, thanks very much.